his PhD degree in 2013 under the Jadavpur University, but his working place was SN Bose National Center for Basic Science, Kolkata, India. Dr. Giri has also completed his postdoc during March 2014 to August 2015, that is 1.5 years, from the National Hui University. Dr. Giri actually expert on computational skill like programming language Python, R, Fortran, C, OpenMP and MPI, GW Basic and Q Basic, Visual Basic, Turbo Pascal. He is also expert on software package. He has developed different softwares like SCI Lab, MATLAB, various cloud-based ICT tools, Anaconda, Eclipse and RStudio, Shell scripting, LaTeX and mathematics, AppTools and VSoft, Sapphire Mongo and Golden Sapphire, MS Excel, MS Access, XMP, HTML and PHP. Not only that, he has the large experience in research also. His research interest on machine learning, theories and applications, computational geometry, numerical simulation and parallel computing, computational astrophysics and cosmology. Last two is very interesting also. He has published more than 20 papers in SCI Index and Scopus with high impact factor. Out of them, one is most remarkable, that impact factor is 18.5, published in 2024 in the journal Advanced Functional Materials. So this is most remarkable. He has presented 36 papers in different symposium conference and he has published 16 book chapters. He has also offered 12 program under MOOC SWAM program, UGC. And Dr. Giri has organized 13 international as well as national conference seminar, different FDP programs. Not only that, he is also reviewer and editorial board member of different national and international journals. So this is the brief CV of our eminent speaker, Dr. Kinsuk Giri. Now, I request Dr. Giri to deliver the lecture on fundamentals of Python and NumPy, that is numerical Python. And it is connected with our pre-lunch session, that is Dr. Nondi has delivered an impressive lectures on fundamentals of Python, and it is also continuation of that part, that is fundamentals of Python and NumPy. So I request Dr. Giri, please start your presentation. Dr. Giri is also personally known to me, and his father is also, once upon a he was my colleague and I have worked with him. And at that time he was very little, that is schoolboy, I met with him. But today he is now our eminent invited speaker. So thank you. Please start, Kinsuk, your presentation. Okay. No, you are muted. You are muted.
Okay, now am I audible?
Yes, yes.
Okay.
Yes.
So, namaskar. So, first of all, thank you. I would like to thank Dr. Sukumar Mondal. He was my father's colleague, and as he mentioned, maybe I can't remember. He saw me in my childhood. That time, so very nice to see you after a long time, although
Yes,
in
yes.
the online platform.
So
So, and
virtually.
thank you for inviting me, and I would like to also thank to the organizers for inviting me in this workshop. So, in this lecture, I think already Dr. Utpal Nandi started the basics of Python, as I know because Dr. Noi already mentioned me. So, I will mainly start on after that. And in today's lecture, I will mention or I will emphasize on the NumPy applications of Python in context of numerical and computing mathematics. So, I will share my slide. I will share my lecture. So, let me share my slide first. And first of all, welcome to all the participants who are joining in the lecture. I understand after the lunch, it's very much tough to continue this session.
And not only that, lunch period is also 8 minutes reduced already.
Okay, fine, fine. So anyway, and just one announcement that during my session, since it will be an interactive session, you may interrupt me if you have a doubt. You can ask me the questions, or if you feel that no, I will ask in the question at the end of the session, you can ask. However, I always prefer to interrupt me and ask some doubts or questions if you have. Anyway, so now let's move to the slide. So I am sharing my slide. Just 1 minute. Okay. So is it visible?
Yes,
Okay.
yes.
Thank you for the confirmation. So the title of my talk is numerical computation using Python. Although I will mainly emphasize on NumPy package as instructed by the organizers or I by organizers. So these are the outlines of my lecture. So first I will discuss on the introduction to scientific computing because since we are learning or we are teaching Python, so we should know what is the background of these tools. In order to know that, we should know the scientific computing tool. Okay, one thing I just forgotten. So maybe maximum participants are Bengali here.
No,
So
sir. Some of them is
oh,
outside,
okay, fine, fine,
different part
fine,
of the
fine,
country,
fine, no issue.
and
But
most
if
from Bengal.
somebody feel or some students feel that he is comfortable in Bengali, maybe he or she can speak in Bengali for asking questions. Okay, no issue on that. So first is introduction to scientific computing, then the NumPy package in Python. That is, I'll cover half an hour. Then I will shift it to the visualization in Python because this is a mandatory part after the basics of Python in order to the graphics part. Graphics, in order to visualize the graphics part, and obviously I will show you the few small basic numerical problem solving with NumPy. And at the end, since it's a talk with the mathematics background people, so I will do a simple experiment with our popular Cauchy's root test using NumPy with for various functions. And obviously, the questions and answers session must be there at the end. So I can see now it's 1:40. So I will try to finish my talk by 2:45, and maybe last 15 minutes we can have the introduction session or zero hour kind of thing. That means anybody can ask any questions. So first part I will show you what is scientific computing. So if I say scientific computing is nowadays obviously it's a third pillar of science. So if I say this answer, third pillar of science, obviously maybe your anxious mind will ask you two questions. So what are the two questions? What are the first and second pillar of science? So is there anybody who know what is the, or you can guess the answer? Can you guess the answer? What is the first and second pillar of science? You may give your answer via voice chat or text chat, but I will prefer to interact via voice chat since I am in the full screen mode. So voice chat is most preferable compared to the text chat. So anybody, any idea what is the first and second pillar of science? Because I am telling scientific computing is the third pillar of science. Why it's third pillar, that I will explain later. But first let me know what are the first and second pillar. Anybody? Okay, so I am giving the answer. The first pillar is called the observations or experiment, and second pillar is called theory or definitions. Because in context of science, the first thing that comes to our mind, that is called observations, or in another word, experiment. Then the second pillar is called theory, definition, and the third pillar is called the scientific computing. So if you ask what is scientific computing, you can find lots of answers. So I have just copied a definition from Wikipedia. So it's a field of study concerned with constructing mathematical models and numerical solution techniques using computers to analyze and solve the scientific and engineering problems. So if you see the keywords, the numerical word is there, computer word is there, mathematics is there. So that's why, in context of any kind of package, these three keywords are very much important, as well as the scientific computing. So what are the scientific computing? I can show you a simple example. Suppose I want to calculate 0 to 2 x squared dx. So obviously I can use the definitions of definite integral that comes from Riemannian integration, and you can find this set by 3. So here there is some theory or the second pillar that is helping me to find the solution. In fact, if I go to this integration, again there is some definition of Riemannian integral for the definite integral, and I can find this thing. However, if I want to calculate, say, minus infinity to x is 5, this integration, the first pillar actually fails, because by Riemannian integration you can't solve this. No theory is there. Another thing is that whether we should stop here. The answer is no. So in that case, what we can do, we can solve it via numerical methods. Maybe the trapezoidal rule, maybe the Simpson's 1/3 or 3/8 rule, or other methods. So these are the part of this numerical computation is the part of scientific computing. Now the questions are that whether we will calculate by hand or by computer, that is a different story. But scientific computing can be possible in both by hand or by human or by computer. Generally nowadays we rely on computer. We don't have this enough enthusiasm and time and also capacity for hand calculations. So that's why we need the topic scientific computing with some tools, like say somebody say Python, somebody use MATLAB, somebody use some cloud-based tool and other tools. And that's why you are here to learn this cloud-based or non-cloud-based tools like Python here. So that is the importance of scientific computing. So while the theory fails, while the experiment fails, then this third pillar that I mentioned just helped us to rescue from this danger. So in a word, I can give some another aspect of importance of scientific computing. Like sometimes the problem that the hand can be solved by the traditional experiment. Like if I want to predict the climate change, I'm sure that nobody has some certain theory or definitions for this climate change. Maybe you have some hypothesis, but hypothesis cannot belong to a theory. So in order to predict the climate change, or maybe in order to predict the tsunami or earthquake, you don't have any firm theory so that you can 100% certain that it is there. That means, in other words, there are no such deterministic theory for this science. Just excuse me, one is in phone call. Hello. Okay, whatever. So this is not possible in the by the second pillar of science. But what we can do, suppose I have last 10 years data. So I just approached to IMD, Indian Meteorological Department, or some other agency, private agency, and they provide me the data. And using those data, I can build a model using the scientific computing. Maybe I can use some statistics and mathematics like machine learning or deep learning or whatever maybe, and I can predict. So this part is called the third pillar of science. While theory fails, it helped us to rescue. Now, sometimes what happens, the experimentation may be dangerous. How? If you are calculating the toxic materials, suppose you are working on some dangerous materials, which is very much harmful for your lab students. So, although you have the scope of experiment, but here the experiment fails. So, the question is that whether you will stop your research, the answer is no. So, we can still continue the research using the scientific computing. Maybe there is a topic that is called solvation dynamics. Maybe those are from physics or chemistry background or material science background, they may know, which is very much popular nowadays, where we are simulating the properties, we are analyzing the properties of materials using this solvation dynamics. We have long programs or packages, we run it for different materials with different constants, different temperatures, and we can have some analysis. That is the part of scientific computing. In third case, sometimes some problem would be too expensive or time consuming to try to solve by other avenues. Like, suppose I need to determine the structure of proteins. I understand it is possible, the instrument is there, but unluckily, the cost of the instrument is maybe in millions or billions dollars. So for a common people or common academician or common researcher, it's very much tough to continue the research. So you can still continue the research using this scientific computing. You can simulate the protein structure in lab and you can do the research. So this is called scientific computing, and mainly 4 things are important in context of this scientific computing. First is called knowledge of the underlying problem. Suppose you are working on rocket science, but you don't know what is the meaning of velocity. You don't know what is the meaning of escape velocity. Then your working will be meaningless. So first thing that is mandatory once you are doing scientific computing on a particular topic is knowledge. Second is called ability. Obviously, you need the ability to mathematically formulate it. You know the velocity, but you don't know how to represent the velocity, that is dx dt, mathematically. So this is also important. And third thing is that you know the mathematical representations, but you don't know how to solve. Because you know 99.99% equations for both OD and PD, or even some algebraic or transcendental equations can't be solved by theory. That's why we need this scientific computing or numerical methods for that. So you need to search for these stable and accurate numerical schemes. And the fourth point is that efficient implementation of high performance computers. That means you need not only the programming, not only the solution, you need the high performance computer HPC for solving. Because nowadays we deal with big data, lots of data are there, lots of things are there. So in order to minimize the computing time, or in order to optimize the computing time, we need this kind of high performance computers. So since we are discussing the scientific computing, our discussion will be incomplete unless we mention these two legends. So in the left hand side, this fellow is von Neumann and this fellow is Hermann Goldstein. So these two fellow has written a nice paper in 1947 while India got independence, with the title of the paper is Numerical Inverting of Matrices of Higher Order. And this was published in AMS, American Mathematical Society. Still you can find this paper in Google. If you are interested, you can go through the nice paper. And it is believed that, why I mentioned the paper name, it is believed that this paper is the first paper in context of this subject that is called the scientific computing. Maybe you heard the name von Neumann, who has given the first architecture of the computer, and Charles Babbage was first given the hardware architecture, the hardware structure. And these are the evolution of the computer programming languages. Maybe you can see Hex, Assembler, C, Fortran, C++, Java, Ruby, all are the time evolution of programming languages from low level to high level languages. But nowadays, from mid 85, 90s, the concept shifted from the programming languages to packages, because you know, in packages, lots of libraries are there, lots of background programs are there. So the users only need to use all those existing library. In this context, first the commercial software came like MATLAB, MATCAD, and Mathematica, and later GNU, Octave, Scilab, FreeMat, R, Python, all these open source software came. So these are the logos of all software. I think you know the logos. This is the logo of MATLAB. Actually, it is developed by the MathWorks in USA. So do you know the full form of MATLAB? Anybody? Because you know MATLAB is very common software to us. Generally, we use it for the scientific computing.
Mathematics laboratory.
It's not mathematics, it's matrix laboratory, not mathematics. Matrix laboratory. I think Scilab, you know, Scilab is an open source alternative of MATLAB, similar to MATLAB. But since it's open source, lots of patches are there in Scilab. But Scilab is good enough for diploma or degree students, because it's free, you don't need to pay for it. And you know, this is the logo of Mathematica. Those who mainly use the symbolic computing in mathematics or high energy physics, they generally use it more. And those who are working on computing, they generally use MATLAB. But both are actually paid or commercial, having this renewable license. Maybe you know there are two types of license. One is the perpetual license and one is called the renewable license. But both of the software comes under this renewable license. And that is the logo of Python. You can easily see, name is there. R is there. R is very much good software for statistical analysis. Those who are working on statistics, R is very much important to them, or data analytics. And this is the logo of GNU Octave or GNU Octave. This is also open source tool, mainly based in the Unix or Linux platform. So these are the benefits of Python. It's free and it's useful for various domains in engineering and science. It's available for each of the operating system, Windows, Linux, and Macintosh. Since it's an open source, so the users have the access to the source code, so that the user can modify or edit the source code. And obviously you don't need to pay for it. That's why free. Now I am coming to the main theme of this today's lecture, that is called the NumPy package in Python. The second part of my talk. So what is NumPy? Obviously NumPy is an add-on package. I think you know the meaning of add-on package. So NumPy does not come with the basic Python. Like in basic Python, some including packages like say stat. is a package that includes in basic Python. Map is a package. Def is a package, library. But NumPy is not included in basic Python. You need to install it in different IDEs. So NumPy stands for numerical Python. That's why NumPy. The name NumPy stands for numerical Python. And it's used for working with the arrays. And it is first created in 2005, although Python is developed from 90s. And it is developed by Oliphant in 2005, Travis Oliphant. Obviously, it's open source as in Python. And it also has the functions for working in domain of, like say, linear algebra, because it is to array, Fourier transformation matrices, and lots of applications. Even reading a CSV file or TXT file, you can use the NumPy package. Because you know, in NumPy there is a sub package load text, sub library in NumPy also for this. And it provides the ND array. ND array, that means multi-dimensional arrays. Sometimes we call it features. Mainly the computer science people or engineers call it features. We the science people call it dimension. Both are same. Now, why it's for mathematics? You know, it's very much efficient array for operations. It's a built-in function for linear algebra, Fourier transform I already mentioned, computational models, data analysis, simulations. It supports integration, differentiation. In obviously integration in like some rules like Tabuada rule and other rules. And differentiation means in like say finite difference method, because it gives the numbers, not this symbolic computing. You should know the difference of symbolic computing and the numeric computing. Like, you know, if I say you 0 to x dx, that is the example of symbolic computing, because the end product will be an expression. But if I say 0 to 1 x dx, it is called the numeric computing, because the end product or the output will be the number. So that is the difference of symbolic and numeric computing. NumPy is mainly used for the numeric computing. NumPy is not useful for the symbolic computing. Now, since also it's a Python workshop, I should mention, you may ask, so how we can continue the symbolic computing in Python? For that, we call, there is a package which is the elder brother of NumPy called SymPy. Maybe you can note down, or maybe you can use the package SymPy, SYMPY, SymPy. So SymPy is the big brother of NumPy. Although in my today's lecture, I will not cover SymPy too much. And NumPy is believed to be the backbone of SciPy. SciPy is a statistical package, statistical Python. And Pandas, SymPy for symbolic Python, SciPy for statistical Python, NumPy for numerical Python. Pandas for data framing, and scikit-learn, mainly those who are the beginner in machine learning. For both the supervised and unsupervised learning, NumPy plays a different or important role. Because, you know, in context of machine learning, the data pre-processing is very much important. And in context of data pre-processing, like changing the shape of the data, reduce the dimensions, or normalize the data, NumPy plays an important role. Another thing is that how can we set up NumPy? So that is different on different IDE. IDE means integrated development environment. In case you are using the official Python, that is called IDLE. That is the inbuilt official Python integrated development environment. For that, you can install pip install NumPy. If you use Anaconda, which is again a third-party software that Python includes there, for Anaconda, NumPy is inbuilt. You don't need to install. But in normal Python, you need to install using the command pip. Pip is the software Python package installer or package manager, by which you can install various packages in Python. I am showing it in the hands-on, please wait. Generally, we need to import the NumPy, and the convention is that we can take the alias np, because we don't want to write the whole name again and again. So I can give the alias. That may be np or np1 or maybe whatever may be. Generally, we write np. And it works with the Python, all the latest versions. And as I mentioned, in Anaconda, it's already bundled, inbuilt. And you can check whether NumPy is installed or not. And if it is installed, what is the version of the NumPy, you can check. So I am now doing the same thing here. So I anticipated, now, by now you know how to install Python in your machine. And maybe you have installed Python. So I will show you how to check the version. So I will show you in both in Anaconda and ideally. I generally prefer to use ideally because ideally very much fast. So I am opening my ideally window. It's opening, please wait. Yeah, can you see my ideally window?
Yes, yes, sir.
Yes, sir.
Okay. So in my ideally window, I can just check whether it's not import NumPy. So the system is searching and showing fine. That means NumPy is installed. In case it is not installed, so how can I install? I can go to my command prompt or DOS mode, sometimes called DOS mode. Go to command prompt window. Yeah, this one. Yeah, it's opened. And just here type, I open twice, pip install NumPy. Provided I need the internet connection. Unless internet connection, pip this installation. Yeah, and it's showing that the requirement already satisfied. That means NumPy is already there. Now, how can I check my NumPy version if it is installed there? Just print np dot underscore version underscore. I can just paste it, enter. Okay, np is not there. I need to write np alias. I need to mention the alias. Yes. Otherwise, I need to write the whole thing NumPy. Okay. Yes. Now you see it's 2.2.4. Similarly, I have already installed Anaconda in my system. I can open Anaconda. Yeah, Anaconda is opening. Anaconda is very slow software. It takes time, so please wait. So may I know which kind of IDE you are using for Python? Anybody? Yeah, Anaconda is opening now. Please wait. Yeah, Anaconda is now opening. So ID I can say 2.2.4. Actually, Anaconda is a heavy tools. That's why it takes times. Okay. Yeah, you see it's loading. Still it's loading. Yeah, now it's opened. So in Anaconda, you have lots of platform like Jupyter Notebook. Even in Anaconda, you can file RStudio. There is a tool called Spider. So I generally prefer to use this Jupyter notebook. If I generally I don't use Anaconda. If I use, I can use. So I can launch it here. Yeah, it's opening. Yeah, can you see this Jupyter notebook now in the browser?
Yes, yes, sir.
Okay, so here I can click a new. You see Python 3 is there. I can click here. It actually today my machine is slow due to some background work program is running in my machine, so that's why it's taking time. Please wait. Yeah. So I will now here import NumPy. So I can run the line first. Now I can print the same version and run it. Here you see how old are it's 1.2.1.20.1. The NumPy older version is because my Anaconda is the older version. Similarly, there is a cloud-based tool, cloud-based platform in for Python that is called Google Colab. I can search Google Colab and I can see the NumPy version of there. So I am now opening Google Colab. So it's opening now. Yes. So here I can click a new notebook. Yeah. So here I don't need this help. Here I can import NumPy as NP, run it. You see how slow Google Colab. So that's why I suggest don't use this Google Colab for your programming purpose. It's a cloud-based tool and takes time. Yeah, it's run. Now I will add one more line here. That is print this. So I can copy this line. I don't need to type and paste it here. And I can run these two lines together. You see in Google Colab the version is 2.0.2. So what I see in my ideally it's 2.2.4. It's 2.0.2. So that is the advantage of using the official Python. That is ideally, because ideally means automatically it is from python.org. That is the official version, and it is always updated compared to the third party like Jupyter Notebook or Google Colab. Even in Google Colab, they are giving me the older version. Okay, so that's why I always prefer to use this in here. Okay. So now I'm just closing the Google Colab, or it may open, no issue on that. I can go to the PPT once again. Yes. Now I am coming to the part NumPy array fundamentals. So it defines 2D. We can define 2D and ND arrays in NumPy. There is a flattening option in NumPy where a multi-dimensional array can be converted to a single-dimensional array very easily. There is an option of reshape, concatenate, and split. I will show one by one with some demonstration. And also there is an option for zeros and ones and arrange an array. So I will show you the examples one by one. So first I will show the example that is called, I have taken an array, np.array, numpy.array, 1, 2, 3 and print array. So let's see what happened. So I am going back to the ideally window. and I'm just copying this first 3 line only. Or I can show in the Jupyter notebook also, no problem. Can you see my Jupyter notebook?
Yes, sir.
Yeah, now I just
Yes.
in the font size. Okay, so I am just inputting numpy here, and I am creating a variable and taking the array with the list. I think you know that by now you know the list in Python. So list. So I am converting from a list to an array. So just run it. So you see it's a now array. So if you see the class now, so type of AR you can see, run it. You see it's array because I have converted to an array. Now, how can I create an array with these 2 vectors or 2 lists? You can check it. Just copy and paste because I don't have time to, and run it. So you see it's 1, 2, 3 and 4, 5, 6 together. It's an array. Now I will show an example of flattening. So for that I am taking a vector 5, 6 and 7, 8 an array, and let's print this race, where race is a dot flatten. So let's see. Okay, I can run also here, no issue. Run. Oh sorry, for that I need to use this new window. There is a multiple line program. So I can save it in a file, a test. I need to import numpy here because numpy is here. Import numpy as np. Now save it and run it. Now you see 5, 6, 7 were 2 lists flattened to a single dimension, and you can see the final output 5, 6, 7, 8. Same code say I can run in Google Colab or also just copy the thing, whole thing, and run it. You see the output is 5, 6, 7, 8. Okay. Now I am showing the example of concatenate. Suppose I am taking 2 array, and if I want use the word concatenate, that will same output as flatten. So let's try it. For this I am trying in Jupyter notebook. So I am just using different environment just to show it. You see now it's 1, 2, 3, 4, 5, 6 together. So concatenate is helping me to add this to list or array. Now I am coming to what? Reshape. Okay, split. You see there is an array from 1 to 6. I want to split it. So let's see what happened. I am copying this part and running it in Jupyter notebook. Okay, sorry, I had it type mistake. This will not be there. Yes, now you see 1, 2, 3, 4, 5, 6 is segregated to or split to 3 parts: 1, 2, 3, 4, and 5, 6. Now let's see the thing
Sir, what is the difference between flattening and concatenating? The outputs are same, sir?
Yeah, actually both are same with 2 different sub patterns, sub routines, or 2 source codes. The output will be same. The purpose are same. You can use any one. Okay. But one advantage is that in case of concatenate, flatten is only applicable for the array, but concatenate even works for list and tuple also. What's my point?
Yes, sir. Yes.
but flatten works only for the array. Now I am coming to the reshape. So let's try with the reshape. So I am taking an array. This is a command line. I think you know hash is the command line in Python. So I want to make it 2 rows and 3 columns. So I am taking a new variable np.reshape, numpy.reshape the main array with 2 by 3 matrices and run it. So can you see now 2 by 3? So I need it 3 by 2. Save it and again run it. Now you see it's 1, 2, 3, 4, 5, 6. Okay. So in this way, you can play with the various kind of operations with NumPy or NumPy or numerical Python, whatever it may be. Second, linear algebra applications. Suppose I have 2 matrices. So I have a first matrix A to 2 by 2 and a second matrix to 2 by 2. I need the matrix multiplication. I need this determinant of the matrix, eigenvalues and vectors, and I want to solve this system. Ax is b. So everything I can do in a single system. So let me start with first this product. Up to this. So I am going to the notebook. Yeah, can you see this in the notebook?
Yes.
I am putting NumPy. I am taking 2 matrices. I have taken an extra that I can comment now. Later I need it. So I am just multiplying AB. Just run it. So this is the AB multiplication. A at the rate B. Okay. So that if you multiply these 2 matrices, you can find it. Now, if you want the element to element product, so what you can do for element to element product, NP.
Is there any restriction of multiplication order? Means
No restriction. No restrictions.
Means 10 by 10 allowed?
Yes. Yes.
Okay.
No restrictions. But in that case, the computing time will be high.
Computation time is high.
Computing time.
Yes.
Okay, now one good question. How can I calculate the computing time? For that you say import time. Then say start is time dot start. That means your clock start, or you can say S1. And maybe at the end you can write say S2 is time dot end. Then total time, total execution time equal S2 minus S1. Let's run. Okay, no, some problem is there. Time dot start. Okay, just let me check whether the format is correct or not. Just wait. Yeah, time dot start is okay. That's not that's not any. Oh, sorry, time dot time. It's telling time dot time. So I can write here time dot time. That means just start the clock and end the clock. So here I can write. So I can copy the whole program once again in the new window. So here in time dot time, not start. time dot time, and here time dot time. Now I think it will work. Yes. Now can you see the execution time?
I have. It is
Yes, sir.
visible.
Okay, now suppose I want to increase the matrix size, say 2, 1, 4, say 1, 3, 5. So I want need a 3 cross 3 matrix. Okay. And maybe say 4, 3, 5, 7.
3 by 3.
Okay. And maybe I need one more matrix, 4, commas, 0 or 3, 1, 5, 5. Or maybe I can give a comma here, second row, third row. 3, 4, 1, just some random numbers. Okay, now if you run the program, I am copying the same thing here and run it. Now you see the execution time is less, but it is uncertain. Usually it should high, but it some random works here. Even if I run once again, you see it's more. You see it's random because it's a very small matrix. In case of large computation, you can find the difference. Okay. So in this way, you can find this execution time. You can again run it. Yeah, you see the different times. So it generally differs. Maybe I should try also in Colab. I am sure Colab will be more slow than it. Let's see. Run it. No, it's showing fast. Okay, now let's try in ideally. Let's try.
Sir, one question.
Yes, you see ideally. Yes.
If we consider this program in C or C plus, and then the execution time, and in that case, which over less? Most probably this.
Obviously, C will be less because Python is an object-oriented programming language, and C is a classic programming language. Because you know, in object-oriented programming language are slower than the classic programming language. It's obvious. So C will be the more faster than Python.
MATLAB.
MATLAB is same as a Python, object-oriented language.
Okay.
That's why you know those who are using the parallel computing.
Yes.
They are using only OpenMP, MPI in Fortran or C. Maybe you heard the term MPI or OpenMP. All are developed in Intel. Only developed for C or Fortran because these are the classic and fast language. So obviously Python is the slowest one. Okay. Generally for high performance computing, Python is not a good programming language. Got it?
Yes.
Fine. Okay, now I missed the actual thing. So here you see, I can show you. So how can I see the product? Here I can print the dot product, element to element product, ETP, which is nothing but np dot prod. I think. Let me check the common one. Yes, in np dot, not prod. np dot. I think the syntax is A, comma B. I'm not sure on that. Let's see. Let's forget the syntax. Let's try. Yes. You see now it's element to element. No, it's same thing. Not dot. Okay, np dot dot and this giving the same thing. But there is a comment for element to element product. I forget the actual comment now, but there is some comment. You may search later, but these are the same output. So these are same. At the rate and end node are same. Determinant. So determinant means np dot this. So I can try it. So I can entirely copy the whole program up to this, up to determinant. Okay. So let's try. The Jupyter notebook will be more faster compared to this. For these two vectors, run it. So determinant is 5. So I want to round the number. So I can round up to say 2 decimal places, comma 2. Now if you run it, some syntax error is there. Wait. Okay, I missed one bracket more.
Parenthesis missing.
Yes. Run. No, still one bracket less. Round. And now I think it will work. Let's see. No, still some errors are there. Let me check. Round. This bracket is redundant. I don't need this bracket. Now it may. Yes. Now can you see? I rounded it up to 2 figures. That's why 5.0. Okay. Now I can find the eigenvalues and eigenvectors for the same matrix. You can change the matrix later. So I am editing in the same program. I don't need to write. That's why I am using Jupyter Notebook. So these are the eigenvalues and the eigenvectors. In Python, it is calculated using this numerical method. Okay, so that's why you are getting this fraction. And then I can solve the entire system. Ax is b. And run it. So x is 1 and y is 3, two variables. So in this way you can continue this calculation. Now I am coming to the numerical differentiation, not symbolic. Be careful. So it is use this finite difference method. Maybe you know f dash x is nothing but h tends to 0, f of x plus h minus fx by h. So here I have taken a small h. Suppose x is a function x square, and I am finding the derivative at x equal to 2. So I am calculating the lambda function with the value. Then I am just calculating this f of 2 plus h means x plus 2 plus h minus 2 minus h by 2h, central difference. So let's try it. Okay, I can try in ideally also once. Yes. So let's try the value. Yeah, you see the value is nearly 4. Let's take a small h, okay, 2 only. Then again try and run. You see, there is some error. The error is more compared to this, because you know h is less means again take less s. Save and try. But you see, luckily I got the good result. But it's a simple function, that's why. Maybe I can use the forward difference, say 2 plus h minus f2 by h. So let's save it. Give h is 4. and run it. Okay, maybe I missed one bracket. Yes. No, still one bracket is there, I think. I think this will work. Yes. So you are getting the derivative, number derivative. Similarly, I can go for integration, numerical integration. So using the trapezoidal rule, I can calculate it. So that is a simple example. I have taken a function x square and I am taking the integration from 0 to 1. So what I am taking in between 0 to 1 interval, I am taking lots of points, 1000 points. And I am finding the area of 1000 simple rectangle as per the theory of trapezoidal rule and summing it and find the area. Because you know integration is nothing but the area. So let's run the program once. I can use in Jupyter. Okay, I can use the Google Colab now. So I am mixing 3 IDE together so that you can see the uses of all the 3 IDEs. Okay, Google Colab is not allowing me to copy, no issue. Maybe due to the security reason. And this is the answer. I can round it. Round say up to 1 decimal places. Then again run it to see 0.3. Okay.
Sir, TrapZ is already inbuilt.
Yes.
Sir, that area equals np.trapz. So
Yeah,
that is
TrapZ is already there under this NumPy package. Trapezoidal rule is there.
okay.
You can write your own program, but no need. TrapZ is there. Okay. Only you need to find the function and all the interval points. Because if you print x is nothing, is all the intervals point from 0 to 1. Got it?
Yes, sir.
So I need say -1 to say -5 to 4 to plus 8. Just run it, and you can see.
This is the result.
Yeah, I need to run it, and you can see the result. Just wait. No, I need to copy because I have written something. That's why I need to copy again. Wait. Yeah, 192. Okay. I can less the number of points. In that case, the accuracy will be less. Let's remove it. Otherwise, it will be 195.6. Okay. Only taking 10 points. Got it?
Yes, sir.
Okay, now I am moving to the part statistics and probability. In NumPy there is mean, median, mode is not there, you need to write, or in the stat package mode is there, stat.mode, standard deviation is there, variance is there, minimum maximum is also there. So let's try with this program. So let me explain the program first. So I am just here randomly generating 1000 numbers and I am finding the mean of all these things. So I am copying the whole program and let me so this is my program. Maybe I am taking 10 numbers, not 1000, 10 numbers. Okay. And using these 10 numbers, I am finding mean, median, standard deviation, and variance. So let's run the program. So I can say the number. I can see the number also there. So these are my numbers, random numbers, and these are the mean, median, standard deviation, and variance. Obviously, standard deviation and variance means it's square. You can see it. Similarly, you can find the max and mean. NP dot max of data. Sorry. Run it. The maximum of this. You see 1.47 is there, I think. Yes, this one. And minimum, I think this will be there. Let's try NP dot mean data. Vector, the vector. Yes, so this one. Okay.
Yes, sir.
Now, what are the applications of NumPy? So obviously in machine learning, in AI, in optimization kind of problem, machine learning is there. Image and signal processing, physics, engineering, computational geometry, data science, statistics, everywhere NumPy or numerical Python is used. Now I am moving to the next part. Maybe that will be the last part because I don't have so much time. So maybe I will wrap up with 10 to 15 minutes. Maybe I need to skip the last part.
Yeah.
Only I will cover this visualization part. So this is the command for bar diagram. There is a command. There is a package matplotlib. How can you install the package? Just go to the pip command prompt. So command prompt is opened now. Yes, just write pip install matplotlib. Enter. In my case, I have already installed matplotlib. So it's telling that requirement already satisfied. That means I have already the matplotlib in my system. So I have two vector x and y, and I am plotting this bar diagram. So I am just copying it, pasting in the notebook, and running it. Yeah, so can you see the graphics?
Yes.
Yes, sir.
So you can save it, but it is the good practice if you save in your system, original system. To do that, you can just write plt.savefig. Say I need in the PDF version, bar.pdf. For the same thing, I need also in the JPG version, plt.savefig bar.jpg. Save it, run it. So automatically the system will save the file in the same location where the program has been saved. I am showing you. Else you need to locate the location. Yeah. Sorry, it's JPG, not GOG. So that's why. Okay, I can go to JPG. That's why the error is there. Yeah. So this is due to this plt.show. And since I saved it, if you see there, can you see this bar.pdf here in the same location?
Yes, sir.
And also the PNG file bar.png.
These are auto created.
Not auto created, I have given the command na
Okay.
plt.save because here I am using the matplotlib package for saving the figure. Okay. I can save from here, but in order to maintain the same quality, it is better to save from the internal command. Got it?
Yeah.
Similarly, you can have multiple bar diagram. I'm going fast because I don't have enough time to think. So for multiple part diagram, I am just copying the, you see there is X and Y and corresponding frequency, two colors. One is color green and one is color by default blue. Color G means green. I can run it. Yes. So blue is the default color. I can change the color. Suppose I need the color as say red. Let's try R and run it. And you can see the legend here. I have used this label. Example 1, example 2. I have given the title, X level, Y level, and title. Suppose here I want to write in LaTeX, say alpha and beta. How can I write? R dollar, you know, in LaTeX it is in alpha. R means LaTeX mode, then dollar beta. So in the title I want to write dy dx is 5, just for fun. Track. I think those who know LaTeX, they already know. Those who don't know LaTeX, they may just see it. Then run it. Yeah. Can you see alpha beta now?
Yes, sir.
And in here you see dx dy is 5. But it. So in this way, you can also write this Greek or mathematical environment in the figure directly. You don't need to use any editor. Fine. Next. So these are the color code: blue, green, red, cyan, magenta, basic color. You can check pie diagram now. So for pie diagram, I need to give the vector. I can start from 0, 0, 0 and go to this original figure. I can write the font size. I can use the shadow. Everything I can do. I'm just showing you. For that, I can use the ideally again, or I can use the noise on that. Just run it. Yes. Now suppose I don't need the shadow. So in shadow, you just write false. Yes. So so I need the font size is smaller or the font is more, text size more. Say up to 2 decimal places, significant digits. Change it. Yes, you see now up to 2 significant figures. I want to change a hello. একটু ক্লাসে পড়ে করছি বলো কোনটা তুমি আমাকে ডাইরেক্ট প্রথমে কল করো, না করলে আমাকে আবার এই কল করো, ঠিক আছে? Okay, so I want to add one more vector here, say togs, just for fun. And that maybe the corresponding value is say 20 or whatever maybe. So initially I need to one tuple here. Rest of the things are fine. Yeah, now you see one vector is added. If I need this shadow, let's write true here. Yes. Of the same program I want to run in Google Colab. Although I don't like, but nowadays people are more interested in Google Colab. So I can run it now. Yeah. And you can see the output in Google Colab. I can also run in Jupyter Notebook. Okay. Next. 2D line plotting. So I need to plot sin x in the interval 0 to 2 pi. So I imported numpy. I have taken in between 0 to 2 pi. In numpy, pi is there. So in numpy, if you want to evaluate pi, you just write np.pi. You can see the value of pi here. Okay. So similarly, I use this one here. So I have taken in lots of intervals in between 0 to 2 pi with the step length 0.01, and I calculating sin x and plotting it, given some name, giving the grid point here, and saving the file name. So I can run the whole entire thing here, save it, and run it. So I can see this plot. If I want to change the color, here I can use color is K, black. Sorry, not this one. K. By default it's blue. K means black. Okay. Now suppose I don't need this grid point, so I can stop it. Grid lines, not grid point, grid lines. You are missing. So you see only the plots. And these are the multiple plot and subplot. Multiple plot means in a single plot, single frame, 2 plots or 2 or more plots, and subplot means different frame. So first I am coming to the multiple plots. You see, I can copy the program. I don't have time to explain, just showing you the thing. You see here are 2 things, S and C, 2 functions, and giving some value, sin and cos. Yeah, so these are the plots of 2 functions, sin and cos, and this legend I can put anywhere, either here, or here, depending on the location. Here you see I have given the location. By default it is the best location. Okay, so I can close it now. And what is subplots? For the suppose I need to plot sin x plus cos x and sin x minus cos x in 0 to 2 pi. So for that I need to use the command subplot. Basically it's a matrix 2 by 1. So 2 1 1 and 2 1 2. If it is 4 figures, so 2 2 by 2, 2 2 1, 2 2 2, 2 2 3, 2 2 4.
Sir, can you show the curve x sine 1 by x?
Yes, x.
X sine 1 by x.
Okay, showing.
Yeah.
Okay, let me first copy it in the notebook. So yes, now tell me which function you want.
X into sine 1 by x.
X
into sine 1 by x.
Okay, and
Sine 1 by x. Yeah.
and then say second function.
No, only single function, sir.
Okay. Run it. No, I think singularity is there for this. Sorry, I need the NP sign. I think also the singularity problem may occur.
Okay.
Let's see. Yes, you see divide by 0. It gives a warning here.
Within the interval 1 2 or 0.12, avoid the 0.
Yes, I can avoid the 0, say 0.1.
Yeah, okay.
Then run it.
Yes.
Then you see no issue is there. This one, this curve.
Excellent.
But it.
No, but sir, you have included 2 curves most probably. But I want to see single curve, x sine 1 by x only.
Okay, then you just you can copy the earlier one, na? This
Yeah.
one. Here.
Yes, single plot.
Here only you need to change sign T star sine 1 by 2.
Yeah.
It will
No range 0 point included here.
it will give the result with some warning.
Yeah.
But it's better you can avoid the singularity. Na? You get 0.001. What is the problem? Then you go through. Then the singularity problem will be resolved. Na? Removal singularity. Yes. Now you see it is giving. Okay. With the no warning because no singular point is there now. Okay. Next. So that is for subplot I already mentioned. Yes. Subplot I should mention subplot once. So let's go to the yes. Run. Okay, now suppose I need 4 plots together. So maybe y1, y2.
Y3.
So, I think y3 is only sin x. Okay, y3. And y4 is only cos x.
Only x or x square.
Also NP cos x. Okay. So now it's total 2 by 2 matrix. First figure. Okay. Then 2 by 2 matrix. Second figure. Then again 2 by 2 matrix. Third figure. Y3. One thing I am doing, I am giving the color, various colors. Don't give the pattern, okay? Just colors. So green, say it's a red, black, and y3 is a black. It is only sin x, and also fourth one is cos x. Y4, it is 2 to 4. Say the color is blue and level is cos x. Now run it. Yeah, can you see this?
Yeah.
Here you see this is mixing with this figure, this font. So that is a single line comment to justify it. ELT dot tight underscore layout. Run it. Now are you happy with this? You see now it's justified with all these positions. So this is very much useful command. Plot dot tight layout. Okay. So that the system will automatically adjust with the best positions. Got it?
Yes, sir.
Next. So these are the markers and style codes, and so first colors, then marker, then line. Suppose I need the marker as star.
Dr. Giri, 5 minutes more.
Yes, I will finish.
Okay.
5 minutes. So maybe this is my second last slide. I will finish. Okay.
Okay.
So this is the. Suppose I want to change the markers. Then I can do it here. Say I want the star mark here. So how can I do it? A G star means star marks. A diamond marks. Say only dot marks. And say only say mark with 1. Then again run it. Now you see So what I can do, I can decrease the step length. I can number point number only 10 points, okay, so that you can distinguish. Yes, now you can see the mark. You see markers. Okay. Now I will just cover 2 more slides. One is for SIMP. I already mentioned how to use SIMP package. To install it, use just simply symbolic Python. The elder brother of NumPy. So that you can calculate the symbolic computing. So let's try the example with SIMP. So I am importing SIMP, giving a function and finding the derivative. And the same derivative at the point is 4 both. So it's now running. Yeah. So you see this is the actual symbolic derivative, and this is the same at x equals to 4. Similarly, you can find the integration using SIMP. So I am giving the integration, example of the integration. So integrate command is there under SIMP, and I am integrating this function in between the interval 0 to 1. Run it, and I can find the value. So I think I should stop here because already the time is only 2 minutes left. So I should stop over here. If you have any questions, you may ask now.
Thank you, sir. Thank you for your nice presentation and nice discussion. So from the audience and participants, I request for some questions.
Sir, I would like to ask some questions, sir.
Yes, please.
Sir, you were able to recall various inbuilt functions. So I would like to ask about is there any book or book chapter where I can get about the inbuilt functions of Matplotlib or NumPy and XMP?
Oh, it's better actually in python.org. Just go to python.org. I am showing you. You should visit the python.org site. So here there is a documentation part.
Okay, sir.
So this is the first one. And second one is that there is an unofficial website where you can find all the possible libraries with their utilities. So I am just sharing the link in the chat box. You can bookmark it. Later you can check. Here you can check all the possible libraries and their works. So you just from this library you click this one. Wheels for Python for Windows, this one. Particularly this one. And you can check all the library. I can particularly this page. Just check, you can check one by one function with their images. Okay. Or you can go to the documentation and official Python website. I can go in the docs in Python.
Okay, sir.
Okay.
Yes, sir. And sir, will we get the access to your PPT files? Like it was very informative, sir.
Okay, I will share with the organizers. Maybe they will share it. Or you can drop me an email with your requirement. I can send you. Okay.
I request you to place your mail.
Yeah, I already given my email. Okay.
Okay, sir. Thank you, sir. Thank you, sir.
Okay.
Any
Thank
more
you.
questions? Any more? No, I think that
Particularly this second link is very much important. Those who are interested on particularly research, this second link is very much important because this fellow worked a lot and given all the possible libraries that are available with Python. Basically, the installation process, that is, we are installing pip.install. There, I am installing the WHL file, wheel file. And here the list of all wheel files are here with the source code. Now you can think how much effort the fellow given for us. Got my point, na?
Yes, sir.
Okay, I think if no more question, thank you once again to the organizer. Thank you, sir.
Thank you, Dr. Giri. You have discussed how can we use this Python programming to solve the harder numerical problem by the single command. So it is very nice. Actually, according to our Vidyasagar University syllabus, in mathematics there is no such Python, but in the physics or computer science they are already concerned about this.
Yeah, but in Calcutta University, they recently added in
Yes,
audit
yes,
course.
yes, yes.
And recently, I visited City College and Asutosh College. They invited me because
Okay.
they are not aware with this kind of Python in their curriculum. So they especially, particularly Asutosh College, invited me 2 times for that, for
Okay.
their faculty development.
Actually, other than our West Bengal, there are so many universities where such type of programming language have been introduced.
Yes, yes, but it must be introduced, particularly Python and R.
Yeah, yes, Python is very simpler, easier, and it is easy to handle. Okay,
Yes, yes,
thank
yes.
you for your nice presentation. From the on behalf of the organizing committee, again, thank you.
Okay, okay, thank you. Namaste.
Thank you. So, dear participants, and this is the end of day 1. We think that you have already learned how to write basic Python code, use variables, and understand how data types works. And also, Dr. Giri have discussed NumPy and visualization also of Python. So tomorrow we will step it up with different lectures, and tomorrow